for a reference.
Okay.
It's just for my reference purpose. So, but actually, a container is a running instance of an image. So, basically an image is a package of our application with certain specified dependencies. So
Okay.
our scripts, our Java scripts or Python scripts, our applications with certain dependencies, we package it into an application, and we create an image. So the running instance of the image is the container. So the container consists of the binaries and libraries from the running image of the application. So container, in reference to kernel, means it makes use of the operating system resources, like our virtual machines or our Ubuntu instances, or yeah.
Very good. So that's about your Docker introduction. Now, when we are going to discuss about the next concept, that is the Docker networking. So what is this Docker networking? So Docker networking, in the sense, how containers will communicate with each other, or else how containers will communicate with the external network. This is what we are going to discuss today. So when we created Docker, when we install Docker on our system, automatically with the help of so the Docker will create a bridge network adapter. This is called as a default network adapter. So this network adapter will help the containers to make the communication with the. So this network adapter will help the containers to make the communication with the internet. Okay. Not only that, if they want to communicate with among themselves, they can make the communication. For example, if I am creating two containers, okay, that is test container one. This is the test container one which I am creating. And there is one more container which I am creating called as test container 2. There are two containers which I am creating, test container 1 and test container 2. So by defaultly, they will communicate with each other. By defaultly, they will communicate with each other. Why? Because they are in a single network. Okay. So if you want to check out that, let me show you this one. Docker run -itd -name test container, or else test container 1. And with the help of Ubuntu image, I am trying to create that container. Okay. So this container will be created. Once the container is created, here you can see Docker PS. So the container got created. And one more container I can create here is Docker run -itd -name test container 2 and again I am going to create that container with the Ubuntu machine only. So if you can see the Docker, so we have test container 1 and test container 2 running. And now if you want to inspect those containers, what you can do, Docker inspect uh, test container. Okay, test container 1. So this will give you the IP address of the container. So the test container 1 IP address is 172.17.0.2. So whatever the container that we have created, by default, it is going to be 172.17.0.2. So the another container which we have created, it is 172.17.0.3. So these are the two containers which we have created. And what I am saying you here, they are created in the default network, or else they are created under the Docker bridge network. So they will have internal communication among themselves through the IP address. So the containers, as they are created in the default network. So let me write like this. The containers are created under default network, default bridge network. So they can communicate with each other through IP address. Okay. Through IP address, they can establish that they can make the communication with each other. So now, so let us see whether they are able to communicate with each other or not. Okay. So for that, what I will do, let me log on to one container, Docker execute -it test container 1 and bash. So I'm inside the container. So we don't have any utilities installed on the container. So now what I will do, apt update -y and apt install -y ip utils -ping and net-tools. Okay, these are the utilities which I am installing on the container. Once I have installed this, so here you can see what is the container IP if config. So the container IP is 172.17.0.2. Now let me try to ping another container, ping 172.17.0.3. I'm getting the response from the another container. So how you can say that that is the IP address of the another container. So I'm exiting from the container 1. I'm exiting from the container 1 and I am logging into the container 2. Docker execute -it test container 2 and bash. So I will be inside this container. In this container also utilities will not be there. So what I have to do, I have to install the utilities. Apt update -y and apt install -y net-tools and what is my requirement? IP utils -ping. Good.
There was a mistake in the install word and still it is continued.
Done. So now, if you can see what is the IP address of this container, the IP address of this container is 172.17.0.3. What is the IP address of the previous container? 172.17.0.2. So the test container 1 IP address is 172.17.0.2 and the test container 2 IP address is 172.17.0.3. Okay. So from here, from test container 2, if I try to communicate with test container 1, 172.17.0.2, I'm able to get the response. So which means that all these two containers, whenever we create a container, by defaultly, they will be created under a default network. So this is called as a bridge network. Okay, bridge 0 network. Okay, under this default adapter, then the containers will be created. But as I already said you one thing, containers are stateless. Containers are stateless, which means due to any reason, the containers can be deleted. Containers can be deleted. Okay. So when the containers are deleted, automatically the IP address will be changed. When the containers are deleted, the IP address will be changed. Okay. So the point what you have to remember, okay, if the IP address changes, then what happens? Is there any fault, any problem? See, there is a 3-tier architecture, web 3-tier architecture, or else here you want to understand what is that. So there will be a web tier. In the web tier, for example, if you want to access any web application, just for example, I will go with the Facebook or Amazon. Okay. aws.amazon.com. Okay. So here you can see an web page has been displayed in front of you. This is from the web tier. Now, when you click on sign into the console, then with the help of it will communicate with the application tier and the database tier. You will be logging into the console and you will be able to access the services. So here, what is happening? The web tier server is communicating with the application server. The web server is communicating with the application server. So we will be writing whenever they want to communicate with each other, definitely in the code we have to write. So this is the application server IP address. So to this application server, you have to communicate. So I will tell to the web server that you have to communicate with the application server, which is having this particular IP. Now, remember one thing, tell me one thing. If we have created the containers under the default network adapter, default bridge network adapter, then suddenly due to any reason, if the container is killed, then a new IP address may be assigned. So if the new IP address is assigned to that container, can the web tier will be able to communicate with the application tier? Are you able to understand my question here? Due to any reason, if the web application or else any application server or else application container is killed or deleted, a new application server we will create and it will assign with a new IP address. When it is assigned with a new IP address, now can be this web application is able to communicate, web container will be able to communicate with the application container. Is it possible?
Yes, it is, because they are in internal to each other.
Because they're under the same bridge network.
But what is the IP address you have given? They might be under same bridge network. See, let me tell you. So there are some neighbors besides your home. Okay, you are having the house number as 101. Okay, besides your home, there is another, or there is a neighbor which is having a house number of 102. Okay, so now, for example, if that 102 house number is a rented house. Okay, now in that there are the neighbors. Now what happened? They have constructed a home with the number 110, and they have, your neighbors has moved into 110 number. Okay, now still you will go to 102 and meet your neighbor, or else you have to go to the 110 house and you have to meet your neighbor. Are you able to understand the question here?
Yes.
Hello.
Yes, yes. But here, where are we exactly mentioning the container's IP address?
Do we need to mention? That is what I am saying. When the containers are creating, automatically the containers are getting the IP address. No. That is what I have shown you in this example also. Whenever I have created, see, the IP address of the container is 172.168.0.3. Here the container one IP address is 172.168.0.2. Didn't I mention that?
Yes, yes.
Now tell me the answer. Is it possible if the container is deleted and recreated with a new IP address, whether one container will communicate with another container through the IP address?
As long as they are in the same range and all, maybe they can communicate.
You are sticking with your word only, right?
Indra.
I think we need to give a naming for that and
We will
associate.
come back to the naming later. I am asking about the IP address. If the IP address of the container is changed, is it possible for the one container to communicate with that container?
No, because I mean, when the IP address changed means that particular image itself got
See,
deleted.
one
So,
second. Now in the Python, I am not writing any Python code over here. Okay, in the Python, what I will do here is SQL connect IP 172.17.0.3 slash student DB. If I give like this, in the application, if I give like this, okay, I have given the IP address and to the database, to which database it has to connect. So in the container, you are having the student DB database. Now there are two containers. One container is 172.17.0.2, which is having the application, And there is one more container that is 172.17.0.3, which is a DB container. Okay. Now, what is happening here? This database container is deleted. Okay. And recreated with the new IP address as 172.17.0.10. This is the IP address that was assigned to your database container, which is newly created. Now, in the program, we have what we are having. The old IP address is there. In the program, there is old IP address only. So now what web application or else what application container will try to do?
We'll try
It
to
will
look
try
up
to connect with the old IP only, and it will be failed to connect.
network failure kind of error message
Right.
exception.
So there will be network failure. That is what I am trying to say you from the past 10 minutes. Okay, anyways. So coming back to the thing here. So the default network adapter cannot help you in this situation. The default network adapter cannot help you in this situation. Why? Because the default network adapter is, or else whatever the containers that are created under the default bridge network adapter, they will communicate only through the IP address only. If one container wants to communicate with the another container through the name ping test container 1, see, with the name they are unable to communicate with each other. But we want the naming convention. Okay. But we want the naming convention to be there. How we can establish the naming convention? So here the containers are unable to communicate with the name when they are under the default network adapter. So for that, what we are going to do here is we are going to create a external network adapter. Here I am just showing you external network adapter. Inside the server only we are going to create. Okay, don't worry that we are creating outside of the server. So we are creating an external network adapter, and these containers will be connected to that external network adapter. Once the containers are connected to the external network adapter, now they will be able to communicate with the name. Okay, so for that, let us create the external network adapter and disconnect the containers from the default network adapter and connect it to the external network adapter. So how I am going to create it here? Docker network create external. Okay, so if you can see here, Docker network ls, see that an external network adapter has been created. So which range it has created? The default range of your bridge network adapter will be, the default range of this bridge network adapter will be in the range of 172.17 series, 172.17.0.0/16. So this is the default range of your bridge network adapter. Mute yourself. Okay, now what I am trying to do, I am trying to create an external network adapter. So the IP address which will be assigned to this external network adapter is 172.18.0.0/16. So in this range, the new external network adapter will be created. If you have the doubt, you can do one thing. Docker network inspect external. Look at that, which range it has been configured for the external network adapter. 172.18.0.0 range will be assigned for your external network adapter. And there are any containers that are connected to this external network adapter? No containers are connected to this external network adapter. So now what I have to do, where our actual containers are there? So Docker PS, if you see here, we have the two containers created, and these two containers are still connected to the bridge network adapter only, default bridge network adapter. So Docker network disconnect bridge test container 1. So I'm disconnecting from the bridge network adapter, default bridge network adapter, and test container 2. Both the containers I am disconnecting. And then what I will do here is Docker network connect bridge test, sorry, not bridge 1, connect external test container 1 and container 2. So when I have connected these two containers to the external network adapter, Previously, we don't have the containers in the external network adapter. Here it is showing the empty space. Now, if you can see Docker network inspect external, previously we don't have the containers. Now we are having the containers, and these containers are having the IP address 172.168.0.2 and 172.18.0.3. Okay. Like this, a new IP address is assigned to the containers. Now, if you log in into the container, docker execute -it test container1 and bash, and if you try to ping test container2, look at that, I'm getting the response from the name also. So if you want to have the communication with the help of naming convention, then definitely you need to create your personalized external network adapter. So with the help of that only, you can establish the naming communication. Remember this, I will ask you whenever we go into the topics, definitely I will ask you this question.
Chaitanya, one question. That /16 means because we are getting everywhere, right? Like 0.0304 everywhere we are getting /16, right? When you are showing the
Where we are getting one,
yeah, 03/16,
/16.
02/16.
Do you have idea about the networking?
No.
If you have the networking knowledge, then if I explain you, then you will understand. But as of now, what I will tell you here is /16 means, so within the network of 172.18 series, we can create 65,000 containers. Okay.
Okay.
There will be /16, /17, /18, /19, /20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Up to 32 you will have. Okay. So majorly you can use up to /28 or 29. Okay. So what is this slash value? Slash values will decide the number of resources can be created in the network. So if I say /16, 65,000 resources will be created. Okay. If I go with /17, then 32,000 devices will be, or 32,000 resources will be created. If I say /18, 16,000, /19, 8,000, /20, 4,000, /21, 2,000, /22, 1,000, like that. So there will
So
be
when you are saying 1,000, right? So is it like 172.18.1.3 like that we will get the IP addresses, or how that happens?
That is how you are going to get the IP addresses. 170. See, any network that
in that third stage where you have 0, we can only have up to 256 as the max number, I believe,
255.
right? Yeah. Then how that will become 1,000? Like, is it after that fourth number will also?
Concentrate on. Can you please hold a second? Let me explain. You have asked me the question, right? Hold on. So you are saying that 172.17.0.3. This is the IP address which was assigned to the container. Now we are deviating from the topic. I don't want to do that, but still, see, this will be like 172.17.0.4. So the range starts from 172.17.0.0. This is the first IP address. The second IP address will be 172.17.0.1, 172.17.0.2. Like that, it will go on up to 172.17.0.255. And then it will be incremented to 172.17.1.0. Now, can you tell me from 0 to 255, how many IP addresses you will get?
256.
255.
256. Okay. So then 172.17.1.1, 172.17.1.2, mute yourself, 172.17.1.3, like that it will go for 172.17.1.255. So here you are having 256, here you are having 256, total 512. Like that, if you see 172.17, 2.02, 2.02, 172.17, 2.255, 172.17, 3.02, 172.17.3.255. If you can see how many IP addresses you will have in these 4 ranges only, you will have 1000 IP addresses,
Correct. Yeah.
right? So if you go up to 172.17.255.255, overall you will have 65,536. These many number of IP addresses will be there. Okay. So if you want, you can calculate that.
Yeah.
So depending on that slash value, we are going to identify how many number of devices we can create. Okay.
And devices means here the
Here the
hosts,
containers.
containers. Okay. Okay. Got
Okay.
it.
Right. So that's about the IP addressing networking concept. So in the networking concept, what is happening here? The networking concept. So if you are having under the bridge network adapter, the containers will not able to communicate with the name. If you are connecting to an external network adapter, they will be communicating with the name. So this is the one. If you want to create any external network adapter, you can customize the external network adapter also depending on your requirement. Okay. So that is about your Docker networking. I hope you understand about this. Is it clear?
Yes.
Okay.
So one other question, like let's say 172.18.03 got deleted, right? As it is stateless, it got deleted, and we created another image which got IP address as 172.18.04. Now, when in your external network adapter, again, we have to configure 04 to use that name, or how it gets mapped?
Automatically names will be mapped to the IP addresses. You don't need to do anything. Automatic resolution will be there.
So we need to use the same name what we have given in the external. Okay, got it.
Whatever the name that you have given for the container, the same name should be there in your application also. Then only the name resolution will happen. Okay.
Yeah.
Right. So that's about your Docker networking. So let us go back for the Docker architecture. Okay, Docker container architecture. So whenever we are working with the Docker, we are giving the Docker commands. If you remember, to create the container, what we are doing, we are going for Docker run. This is the command that we are giving. Okay. To build an image, Docker build. Okay. To check the images, Docker images. To check the containers, Docker PS. Whenever we are giving these type of commands, okay. So the client is interacting with the Docker CLI. So this is called as the Docker CLI. So once we have installed the Docker, with the Docker, you will have the Docker CLI is also installed. So CLI is command line interface. So the command line interface which helps us to communicate with the Docker. That is the Docker CLI. The client will able to communicate with the Docker CLI. Now, whenever the client is trying to communicate with the Docker in this fashion, Docker PS, you are getting the output. Docker images, you are getting the output. Docker network ls, you are getting the what are the networks that you have created. Docker volume ls, you are getting the volumes that are created in the Docker. Right now we did not create, but you will get it. Or else Docker ps-a. Any stopped containers are there that will be shown over here. So whenever the user is trying to interact with the Docker, he is interacting with the Docker CLI. Okay. So this Docker CLI will be connected to the Docker daemon. So there is a Docker daemon will be there. And this Docker daemon is the main component of your entire Docker architecture. Okay. So what is the main? It is like a heart of your Docker. So whatever the Docker daemon that you are seeing here, this is the heart of your Docker. If the Docker daemon is not running, then we will be not able to communicate with the Docker. So see here, what I will do here is systemctl stop docker.service, and at the same time, what I will do, I'm killing the Docker. Okay, that's it. So hold on. Docker.socket. If I stop these two, now when I run the command docker ps, look at that, cannot connect to docker daemon. So whenever you want to execute any commands, definitely docker daemon should be running in the background. If the docker daemon is not running, then you will not be able to execute any sort of command. So docker daemon is the heart of your entire Docker application. So daemons are most important for any application. Either it might be Jenkins, there will be Jenkins daemon. For Docker, there will be Docker daemon. Like that, you will have the daemons. Daemons are very important. So let me start it. Docker systemctl start systemctl start docker.service. Right. So when we have started this, now if you execute the command, so the daemon is giving the response for you. So what about our containers? When I give docker ps, as the docker daemon is killed, the containers are also into the shutdown mode. If you can see docker ps -a, see that exited about a minute ago. So we have to start them, which means that they are shut down. Okay, so now we have to start them. Docker start test container 1 and docker start test container 2. Now they will be in the running position. So docker ps is a command which will be helpful for you to check the running containers. Docker ps -a is a command which will be helpful for you to check the containers that are running or stopped in any state, wherever the state is. It might be created, stopped, running, or else paused, unpaused. Every container will be appeared for you whenever you give the command docker ps -a. All containers will be shown. Either it might be stopped containers or running containers. Everything will be shown when you give the command docker ps -a. Okay, so now when we get back to the things over here, so when I give the command docker run, so I want to docker run in the sense I want to create a container. So the request will go to the docker daemon. Now what docker daemon will do here is it will check in the local registry. It is going to check in the local registry for the image. Okay, so now when I try to create a container, for example, let me try to create the container. Docker images. If you can see here, we have the Ubuntu image. We have the Ubuntu image which is there in the local server. In the local server, we are having the Ubuntu image. So if you try to create a container, docker run -itd -name test container 3 with Ubuntu latest or else Ubuntu. So it is not showing. Why? Because the Docker knows that the image is available inside the local registry only. So we have the Ubuntu image in the local registry only. So what it is doing, it is taking this image and creating the container. Docker daemon is taking the image and creating the container with the help of that image. Okay, so that is test container 3 is created. Now, if there are no images, then what happens? So let me try to create a new container. Docker run -itd -name nginx 1 with the help of nginx image. Nginx, okay. So the nginx image is not available in the local repository. The nginx image is not available in the local registry. So now when I press enter, what Docker is going to do, check out this. Unable to find the image nginx latest locally. So it is not able to find the nginx latest locally. So now the Docker daemon will try to pull this from the Docker hub. So there will be a Docker hub, which is a global registry for all the images. So now what is happening here, this Docker daemon, whatever the Docker daemon that we have discussed, this Docker daemon knows the exact URL of this Docker hub. So it will go to the Docker hub and pull the image from the Docker hub. And pulls the image from the Docker hub. There will be global images. So whatever the image that you want, if you want the Python image, that will be available. If you want the Java image will be available. If you want the Nginx image, that will be available. If you want the Tomcat image, you will have the Tomcat image also. So whatnot, every image will be available in the Docker Hub. So now this Docker daemon will pull the image from the Docker Hub and stores it locally in the local registry, which means within the server. And with that image, it is going to create a new container. It is going to create a new container. So this is how the Docker architecture on Docker daemon will work. So this is the entire Docker architecture. So this is the local repository or registry. Local registry. Docker Hub is the global registry. And this is the container space. Container space where all the containers will be created. So this is about your Docker architecture. So if the image is not available in the Docker Hub and as well as in the local registry, then you have to create your own image. If you want more customized image, then you have to create your own image with the help of Docker file that we will see in the upcoming time. So this is about your entire Docker architecture. Understood?
Yes.
Is everything clear?
So in the command we have given docker run itd nginx twice, right? The name.
What you need to understand here, this is the name of the container. That's why I have given nginx1. Nginx1 is the container name. Nginx is the image name.
Okay, now got it.
Questions?
Since the image is not present, we are giving the image name, so it will automatically pull
If
from
the
it.
image presents also, we have to give the image name. What is that question? You are asking that, sir, without the operating system, we are trying to run the computer. So images are like an operating system for the containers, part of the containers. Okay.
No, okay.
So
No,
without image, you cannot create the container.
okay, I assumed before running we have to like docker pull that image name and then later we have to run the container, and I was assuming.
See, I clearly explained you, if you want to create a container, you need to have the image. Okay. So if the images are available in the local, it won't pull the image from the Docker Hub. If the images are not available in the local, then only it will go and pull the images from the Docker Hub. That's why I have shown you here also. Docker images or Nginx image is not there. Look at that. We have only Ubuntu image.
Yes.
Now, if you can see Docker images, look at that. Do we have the Nginx image in the local registry?
Yes.
So now this time what happens when we are trying to create a container? Look at that.
It will create with the name nginx one. Create.
Nginx 2. Okay. Nginx 2. This time, is it going for the global registry or with the local registry only it is creating?
Yes.
Hmm?
Yes, with the local registry because image is already available.
So that is the concept. Understood?
Yes, understood.
Any questions?
So all these commands you are running on your local virtual machine, right, Chaitanya?
It's a AWS virtual machine.
So you're connecting to AWS. Okay.
Yes. If you want, you can create inside your local virtual machine.
So on AWS, we can have a single EC2 instance, and on that we can install the Docker, and then you're running all these commands, right? So that will go we have to follow. Okay.
Exactly. That is the thing which I'm doing right now. Understood about this architecture? Do you have any questions with the architecture? Okay. So now let us discuss about the container lifecycle. So now we are going to discuss about the container lifecycle. So what is the container? So we are giving the Docker run command. When we give the Docker run command, what is happening? When we are giving the Docker run command, what is happening?
The container is getting created.
Container is creating. Container is creating or directly it is running?
Creating and running also.
So automatically created and started. Okay, a container will be created and started if you give the docker run command. But actually what happens here is you have to give the docker create command. So first what you have to do, you have to give a docker create command. So this create command will create a container. The create command will create the container. This is the first form of your container lifecycle. After that, what you have to do, then you have to go for docker start command. So when you go for the docker start command, then the container will be started. So, but we are bypassing these two commands. Directly, we are going for the run command. But actually what we have to do, we have to create the container and then we have to start the container. So let me show you that one. Docker create -it -name nginx container 1 with the nginx image. Okay, now if you can see here, a container is created. What is that? Nginx container 1. Sorry, docker ps -a. See that? Nginx container 1 is created. Okay, if you can see, these are the 5 containers which are running. But there is one container which is created with the help of the command docker create command. Now I want to start that container. How I can start that? Docker start nginx. Sorry, there is a mistake. Okay. Docker start nginx container. So now if you can see here, sorry, the container is now it is in the running mode. Okay, previously it is in the created state. Now it is in the up state, which means it is running. So which means that whenever we are creating a container, so there will be, so if you want the container to get into the running state, you have to follow 2 stages. One is the create stage and the other one is the start stage. Okay, these are the 2 stages which you have to follow. Next one. So the container is running, that is fine. So now what you want to do? So I want to pause the container for certain reasons. Okay, I don't want to stop the container. The application should be running in the container, but it has to pause for a while. Okay, due to some any external reasons or else any external factors, I want to pause the container. So what happens when we pause the container? Now I have a question for you. You are watching a video in your laptop. Okay, whenever you are watching any video in the laptop, what is happening? The video will be running. So any application that is running in the computer, that will be stored in the RAM or hard disk. It's a basic question. If you are a computer science engineer, you will understand the content here. If any application that is running, whether the application is going to stored in the RAM or hard disk. Running application.
Yeah, it's
RAM.
RAM.
In the RAM.
It is
Okay.
RAM.
In the RAM. So now my point is, when we pause the application, if you pause the video, okay, if you pause the video, whether the video will be closed or else it is paused and it will be restarted from where you have paused, or else it is going to resume from where you have paused.
It is resumed from where it is paused.
Right, which means that the application is stored in the
RAM
RAM,
only. Yeah.
right? But is there any processing happens? Right now, the application is in the rest position. Any application which is in the rest position, does any processing will happen for that application?
No.
No. So the processing will be 0.
Stop.
But have the RAM, right? So that is called as a pause state. So you can pause the container. There are 2 stages called as pausing and unpausing. So if at any given point of time, due to any reason, if you want to pause, this is also one of the life cycle, you can pause the container. So when you pause the container, the application won't be deleted from the RAM, but the processing will be 0. So now if you can see here, Docker, let me log in into one of the container docker execute -it test container 1 bash. I will go inside this test container, sorry, test container 1 bash. So now I am inside the test container. Let me do one thing. Apt install -y stress. What is this stress? Stress is a utility which will create a what I can say virtualized load on the machine. Okay, fake load on the machine. Now, if you can see, let me do one thing. I will go to another duplicate session. Let me take a duplicate session. So look at this. Sudo su hyphen docker stats. If I give this, what are the stats that are saying the CPU utilization is 0%? Look at the test container one. The CPU utilization is 0% and the memory utilization is only 19 MB. Now, what I will do here is I will go with executing the stress command. So I want to execute this stress command for minimum 30 minutes. Okay, when I execute the stress command for minimum 30 minutes, what about the CPU utilization? Look at here. The memory utilization has been increased from 17 MB to somewhere around 200 MB. What about the CPU utilization? It has been increased to 0% to 100%, which means that the stress application is putting the load on the container. Now, what I will do, due to this reason, I want to check what is the problem with that container. So now what I will do here is I don't want to shut down the container. If I shut down the container, again, I need to restart all the applications. So I don't want to do that. So for that, what I will do, docker pause test container 1. So when I pause test container 1, look at there what is happening. What about the CPU percentage? The CPU percentage has been reduced to 0. Previously, it is about 100%. Now the CPU utilization is 0. But what about the RAM utilization? Is RAM is utilizing? Of course, 131 MB of RAM has been utilizing, which means that the application is still running on the RAM, but it is not processing. So that is the reason you can see that the CPU utilization is 0%. Okay, so again, what I can do, I can go for unpausing the container. Docker unpause test container 1. When I unpause test container 1, look at the CPU percentage. Again, the processing is started, so the CPU utilization is increasing. So this is also one of the state. Okay, so that is about the pausing and unpausing of the container. So this is the second life cycle. I mean, in the life cycle, this is the second phase. First one is creating, starting, and the next one is pausing and unpausing. Pausing and unpausing. Okay, the third form will be stop and start. If you want to stop the container permanently, if you want to stop the application of the container, then what you can do, you can go for the docker stop container. You can go with the command docker stop. So the container will be stopped, which means it is dead. The application inside the container is also killed. Okay, so now look at this. Docker stop test container 1. Look at that, the test container, what is going to happen. When I go for docker stop test container 1, hold on. It will be removed from this queue. Look at that. Will not stop it. Hold on. Now the test container 1 is killed. So docker stop means killing the entire application, killing the entire container. And again, if you want to start, what you can do, docker start test container 1. Again, it will be started. So that is what start and stop. But starting and stopping is not that much easy. Why? Because you have to reconstruct the entire application, restart the entire application, stop, and then start. So when you start this, again, the container will be in the running mode. Okay.
So one question here, like yesterday, I think we installed. I mean, we created a container for Ubuntu, and then we added some libraries on that, right? Like network libraries, ping and all. So when we start, we will continue to have those all, or it will be a new image of
Utilities will be there.
all those
Utilities will be there.
utilities will be there. Okay. So the state only the image what we created is just stopped. We can restart it with the same state.
Let me tell you. You have a DVD player. Okay.
Mhm.
It's a olden days thing. Now you are watching a movie. Okay. So your mother said something to bring. So now what you will do, you will pause the movie, go and get back the things, and you will resume the movie. That is pausing and unpausing. Suddenly, when you are watching the movie, the power is off. Due to any reason, the power gone. Now what happens? The entire thing will be resetted back to 0. The movie won't play from the where you are watching. It has to start from the 0 itself, right? Yes or no?
Yeah.
So the same, shutting down. Here also, the container got shut down. But see what is happening. Is there any changes in the DVD player, or else is there any changes in the movie? There is no changes, but it is starting from the beginning.
Mhm,
Okay.
mhm.
So here also the application has to start from the beginning. Okay. See, simply, if you are running a computer, if you shut down the computer, shut down. I'm talking about shut down, not in the sleep mode. If you shut down the computer and restart the computer, what happens? All the application has to restart, right? All the services has to restart. Yes or no?
Yes.
The same will happen here. Okay.
Yeah.
But the application will be deleted? No. In the computer, the application will be there. But what it has to be happen? It should be restarting. It should restart all the services. Okay. So that is
Yeah.
what stop and start. Now the next one is remove command. Docker remove command, RM command. So if you want to delete the container, you can go for the Docker RM. Okay. So when you have to remove the container, when the container is in the stop state. So if you see here, if I try to remove any container, Docker RM test container 1, it won't be removed. Why? Because it is in the running state. See here, error response from the daemon cannot remove the container. Why? Container is running. Okay, so if the container is in running state, we cannot remove the container. See there. Now what we have to do? Docker stop test container 1. Then we have to remove the container. Okay, so if you want to remove the container in this fashion, you have to do this. Or else, if you want to forcefully do this, you can do that forcefully also. Docker RM test container 1. Okay, now we can remove it. So now the point is, if you can see here, Docker PS, there are so many containers. So for every container, you are having a container ID. So if you can see, these are the container ID. To get the container ID, what you can do here is Docker PS-A Q. Okay, Docker PS-AQ. If you give this command, you will get only the container IDs. Now I want to forcefully remove all the containers. If you want to remove the containers forcefully, what you have to do here is Docker RM-F dollar Docker PS-AQ. If you give this, all the containers will be forcefully removed. So if you can see here, Docker PS, no containers are there. Docker PS-A, no containers are stopped. Okay, no containers are running at the same time, no containers are stopped. So this is how you can forcefully remove the container. How I have removed it, -F. If I give the option -F, it is a forceful removal of the container, which we cannot do. So only you have to stop the container, then only you have to remove the container. This is not the proper way of deleting the container. If you delete this time, it is not a proper way. Okay, in the companies, they won't accept this. Understood? So this is the Docker life cycle. where we are having the create, start, and then run, pause, unpause, stop, start, and remove. So that's about your Docker container lifecycle. Overall, in this session, what we have discussed, we discussed about the Docker networking, and then we discussed about the Docker architecture, and finally, we discussed about the Docker lifecycle. Am I clear with this? Any questions? Everything is clear?
Yes.
Okay. Yeah, T2 micro is more than enough, Anil. In the AWS, not much more than that. If you have T2 micro, that's more than enough.
Okay.
I am running T2 micro only. You see, why? Because it's a free tier eligible, no?
Yeah,
I'm
yeah, yeah.
Only
Right.
T2 micro only. Get there. Each type of instance. Okay, that's more than enough. So that's about your Docker. So here ends our 3-day, what I can say, demo sessions by today. Yeah. Helm we will cover. AgroDB, AgroCD, we will have a little bit explanation, not much more than, but we will cover the entire Helm. Helm charts, how we are going to create the Helm charts, what is the basic definition from basic to extreme level, we will cover the Helm. Okay. So yes, I hope you have thoroughly understood what is Docker, and with this explanation, I hope you are okay. So here ends our demo sessions. Okay, Jenkins implementation will be there. Not Jenkins. Jenkins, the total classes won't be there. How Jenkins will be integrated with the Kubernetes, that will be there. It's purely Docker and Kubernetes sessions. So from next session onwards, it will be a paid link. Those who has paid the fee, they can have the separate link and they can attend from next session onwards. Okay. Yeah. Thank you.
We have class tomorrow, right?
Yeah, you are having the class.
Okay.
Same time, right?
So,
8 o'clock. 8 o'clock.
Yeah.
so tomorrow is demo or sir a paid class?
It's a paid link.
Okay. So are you finished with Docker, sir?
No. We have just entered into this. We still have to cover Docker images, Docker volumes, and then Docker Swarm, Docker Compose. There are so many things out there. Okay. Just
Because
I
when I
have
look
given
into
the
the syllabus, only the first part is Docker and the rest is Kubernetes. So
yes. In the first part, we have completed the first introduction.
okay.
If you see the syllabus, you are having Docker introduction, where you are having Docker architecture, Docker lifecycle, and then you are having Docker networking, Docker images, Docker volumes, Docker compose, and Docker swap. With this, with
Oh
the
yeah.
Docker will be completed. And then when you
Okay.
go for the Kubernetes architecture, microservices and monolithic services, difference between microservice and monolithic Kubernetes, and in the Kubernetes, creating the Kubernetes with the help of kops, kubeadmin, rancher, and then we will go with the components of the Kubernetes, pods, and then deployments, replica sets, stateful sets, daemon sets, and then we will go with the services like cluster IP and the load balancer, node port. There are so many things that we have to cover. I cannot explain you. Whichever I have, I already gave you in the first session only. If you have that video, go through, check out that. It will be very helpful for you. Okay. So do you want the project? If you want the project means I will skip some concepts. Is that okay for you? In project, we cannot go for all the components. We cannot touch all the components. We will cover only a few topics in the project. But if you want all the components, definitely we need to go with the raw content. We are going with the raw content, not with the project content. With the help of this raw content, whatever the project that you have appeared, you can do that. Okay, if I say only with the project, I can skip probes. I can skip advanced scheduling. I can skip RBAC rules. If I skip those, when you go for another project, if they ask you over there, then what you will do? Don't rely on the projects. It's a very, very, very bad sign that everybody is asking about the project. So projects are only helpful if you want to get a minimal knowledge. Okay, for a project, there will be limited resources. but we are going with beyond the project. We are going more than the limited resources. We are going to learn about more than what you will learn in the project. Okay, so don't rely on the project. Projects are basic things. Okay. So that's it from my end. Have a nice day, and we'll meet in the next session. Have a nice day, and bye.
Thank you.